In Chapter 1, we're going to be starting to talk about the way to solve problems. And our first section in 1.1 is called Inductive and Deductive Reasoning. In this section, you will learn about inductive and deductive reasoning processes. The set of natural numbers is also called the set of counting numbers. So n is equal to a bracket 1, 2, 3, 4, 5, 6, 7, 8, dot, dot, dot. The three dots, called an ellipsis, means that 8 is not the last number, but the numbers continue in the same manner. Divisibility. If A is divided by B and has a remainder of 0, then A is divisible by B, as long as B is not 0. The even counting numbers are divisible by 2, and they are 2, 4, 6, 8, and so on. And the odd numbers are not divisible by 2, and they are 1, 3, 5, 7, and so forth. The process of reasoning to a general conclusion through observation of a specific case is called induction. In other words, we look at a pattern and we see how the pattern works, and from the pattern we make a conclusion. That's called induction. This induction is often used by mathematicians and scientists to predict answers to complicated problems. So, in our first example, inductive reasoning, what reasoning process has led to the conclusion that no two people have the same fingerprints or DNA? This conclusion has resulted in the use of fingerprints and DNA in the courts of law as evidence to convict persons of crime. So the solution was, in millions of tests, no two people have been found to have the same fingerprints or DNA. By induction, then, we believe that fingerprints and DNA provide a unique identification and therefore can be used in the court of law as evidence. It is possible that in some time in the future, two people will be found to have exactly the same fingerprints or DNA. It's also been found that identical twins do not have the same DNA or fingerprints. The scientific method. Inductive reasoning is part of the scientific method. When we make a prediction based on specific observations, it is called a hypothesis or a conjecture. So here's example 5. We're going to pick any number, multiply the number by 4, add 2 to the product, divide the sum by 2, and subtract 1 from the quotient. We're going to repeat this process for several different numbers and then make a conjecture about the relationship between the original number and the final number. This example is showing you we're going from a specific example to coming to a general conclusion. That's induction. So one of our solutions say, pick a number, say 5. Multiply the number by 4, which is 4 times 5 is 20. We add 2 to the product, and 20 plus 2 is 22. We divide the sum by 2, so 20 divided by 2 is 11, and we subtract 1 from the quotient, and we get 10. So in this case, our original number that we picked was 5, and we end up with 10. Can we say anything about the original number and the final number? Well, it looks like if we did this again, we may see that 5 is twice. 5 times 2 is equal to 10, so maybe twice the original number. Well, let's try again. We started with the number 5 and finished with the number 10. Let's start with the number 2. And if we take 2 and we multiply it by 4, we get 8. We add 2, we get 10. We divide by 2, we get 5, and we subtract 1, we get 4. So that's twice the number here. Now, if we started with 3 and we did the same process, we'll end up with 6, and so forth. So, in some cases, we may conjecture that when you follow the given procedure, the number ending will always be twice the original number. So that is our conjecture. Sometimes, in testing a conjecture, if a special case is found that satisfies the condition of the conjecture but produces a different result, that case is called a counterexample. Only one exception is necessary to prove a conjecture false. That is, a counterexample. If a counterexample cannot be found, the conjecture is neither proven nor disproven, and we have to go through a process of induction, typically. Deductive reasoning, a second type of reasoning process, is called deductive reasoning. Deductive reasoning is the process of reasoning to a specific conclusion from a general statement. So if we have a formula that is generally used to find area for a circle, we can use that formula for every circle of different radiuses. That's using a method of deduction. So now we'll pick a number n. So prove using deduction reasoning that the procedure in example 5 will always result in twice the original number selected. Notice that for any number n selected, the result is 2n, or twice the original number selected. So here's our deductive process. We begin with a general case, and so the general case is we pick a number n. We multiply the number n by 4, and we get 4n. And we add 2 to the product, so we get 4n plus 2. And then in example 5, we divided the sum by 2, so we get 4n plus 2 divided by 2, which is just 2n plus 1. And then we subtract 1 from the quotient, and guess what we get? 2n. So this is twice the number that we originally started with. So in the general case, we said, okay, we pick a number n, and we know that our conjecture is we'll end up in this process that we've created 2n, twice the number. Well, this concludes our discussion on inductive and deductive reasoning, and throughout the course we will talk about processes which are inductive or deductive in nature. So please review chapter 1.1, and the next section to look at is section 1.3 on problem solving.